Hi, in this video we'll be doing a demonstration of a data visualization procedure utilizing a library that is known as ggforce to produce hull plots, which are a great way to show group membership and clusters on a scatter plot if you are having different categories or different groups in your data and you are interested to show a group membership or the clusters around a particular scatter plot. So how we are going to do that? For that we'll be using a library that is known as ggforce, and apart from this we'll be using some other extensions of ggplot2 library, which is a very important library as far as this data visualization is concerned, and we'll be using a certain part of metan also. For that, what we will do, we'll import a data set, and this data set has already been utilized, in my opinion, in a video which was based on group comparison plots, which is available on my channel. So we'll be importing this data set. Okay, we have a data set. Since it is already available in my channel in a group comparison pairs plot procedure, we have three different locations or three different soil locations. One is Shalimar, Vadura, and we have Benihama campus, and we have taken different observations on nitrogen, phosphorus, and potassium. So this is a very simple data set. So the first important thing, whenever you are performing the data analysis in R, I always prefer to write the names of the data set, this function, to see what are the labels, what are the names in my data set. Then the second important thing is to see the structure of the data set. Now this is very important, since if you will see, the locations are my characters, but I have to make them as factors. So how we are going to do, we will write the name of the data set, then put a $sign, then put this categorical variable, then assignment operator function or is equal to function is used, then we will use this function as.factor. Then again I will write the name of the data set followed by this $sign. Okay, if we will see the structure of our data set now, see, the locations are not now characters, they have been converted to the factors. Since when we are doing the data visualization techniques or data visualization procedure, especially when we have some variables, the normal procedure is to make a correlation plot like this, CORR underscore COEF. Okay, then I will write the name of my data set, then I will use these square brackets, comma -1. Since my first variable is categorical, I have to make a correlation plot, which is usually made for only continuous variables. Since I'll be expecting a Pearson's correlation plot, I will click on this. I'll be having a plot here. Okay, we have this kind of a plot, and of course all these variables, both these variables, potassium and this phosphorus and all these, have a positive correlation. Or we'll be using a library which is known as corrplot, which produces some visualization of correlation matrix. So we'll be using this also. Then if we want to make this a correlation plot by means of this library, we will use some function. Say for example, we'll write a name to a function. Then for that, what we will do, we'll first write the name of my data set, then I will use this square bracket, and within this I will use a concatenation function, then these normal brackets, and within this I will write 2:4. Why? Since I have a total number of 4 variables, 1, 2, 3 and 4, but the first one is excluded, so I'll be using the variables from the second variable up to 4th. So second, third and fourth will be included to make a plot. Then I will write some name to a function, then I will write core, which is a default function that has to be executed while making a plot utilizing library corrplot. Then I will write this date, the name of the previous function. Then if you want to see the summary of this, we'll write this res, or if you want to make a plot of it for that we'll be doing, we'll simply write corr plot. We have to use this function, then we will write res, then we'll click on this enter. We'll be having this kind of a plot. If we will do some kind of an adjustment in it, we'll write type, then within these inverted commas I will write lower. We have only lower diagonals. Then if I will write upper, so it is a subjective approach, or if I will write nothing, then we'll be having this kind of a correlation plot where the color, the density of the color will represent the amount or the strength of the correlation. And the normal thing which while doing the data visualization of this kind of a data is to make ggpairs plot, which I have already shown in my one of videos. For that we'll be using a default function ggpairs followed by the name of data set. Then within the aesthetic we have to fill the colors for our categorical variable, that is locations. Then we'll click on this enter and we'll be having a ggpairs plot, which is a combination of density plot, box plot, scatter plot, and the visualization of correlation, which I have already discussed in my video on group comparison plots. Then again a data visualization procedure. For that we will be using a library ggstatsplot, which is also an extension of this library ggplot. And for that, if we want to make certain kind of visualization, then for that we will use this random number generation set.seed. Then we'll be using the function ggBetweenstats, and within this I will put the name of my data set first. Then I will define the x-axis, that is locations, then I have already shown in this kind of a procedure in my one of videos. Then y is equal to nitrogen. Then I can also give the title to my plot. Say for example I will write ggstatsplot for soil data, something like this. So since it is based on the kind of a gadget you're using, the kind of machine you're using, the processor involved in your machine, so as fast as your procedure is processor is, so in the same way this graph will get displayed on the this plot section. So we have this kind of a plot which is known as the ggstatsplot, where you can see the group comparisons also. And the normal way of doing the data visualization in R utilizing this library ggplot is to make the box plot. When you have these kind of data sets where you have different categories and you want to evaluate them, then as usual you write the name of the data set, then you define your x-axis, which is in my data set the locations. Then after that we'll write the name of our continuous variable which we want to put on this y-axis. Or then what we have to do, we have to fill the categorical variable, that is again locations. Then after that, then we will be adding some kind of a noise which is known as jitter in ggplot. Then after that we'll be use this plus sign. Since we want to seek the comparisons, we will use this stat underscore compare underscore means. Then we will use another function that is known as label.x is equal to 1.5 comma, then the method which we'll be using, since we have three groups, we'll use basic analysis of variance. So we'll be having a plot which is a traditional box plot where you can see the different noises or the jitters we have given, and we have a p-value by which we can conclude whether there is a significant difference between this, or we will be using a library that is AgroR, which is a very good library. For that, we'll be using a function which is already written on my R console. First, use the name of the data set, then the default function dic, then the name of these, say for example the objects of comparison. Here we have location, then response variable, then the post hoc analysis you want to perform to keys or HSD, or you want LSD, then you want to have a plot where you want to have the labels on the plot, then you will click on this run. So you'll be having all these analysis of variance, ANOVA table, the assumptions related to analysis of variance also. Then we have a plot like this. Is a very basic plot, and we can conclude here whether all these three different groups are significant from each other. But we are mainly interested to make Hull plots, and for that we'll be using a library ggforce, and along with caveman also. We'll click on this run. Then here we'll click on this like this. We'll click on this. Okay, the package is recalled. Then we'll be using this function ggplot followed by the name of this data set, and we'll be using the default aesthetic procedure where we have to use both these continuous variables. Say we are taking in nitrogen and potassium in this case. Then this geom_mark hull, this is a very important procedure here. If we will click on this, then we'll be having a plot like this. We have plots for Vadura and Hull plot for Benihama. They are overlapping here. If we will customize it like this, instead of Shalimar here, we'll write Vadura. Then we'll be having a plot like this. And if we will use, instead of this function, here we are labeling all the locations. All the three locations will get displayed here. You can see we have Benihama, Shalimar, Vadura as well. Since there is a certain kind of overlapping here, so these are usually used, these group scatter plots are used to visualize the clusters that are present among the data sets. So if you want to put your results, and you have a data set structure like this, where you want to put results, or to show your results in a better way, to make your data more attractive, so you can make use of these Hull plots, and you can use your default data set iris, which is by default present in R. You can perform the analysis to make you more controllable on the kind of coding we do in R. So hope this video will be highly beneficial for all the persons who are seeing this video. And if you have any comments, so you can put them in the comment section. Hope you like the video. Thank you very much.